everybody. My name is Boris, and I'm a tech lead from Wix Bookings. And today I'd like to tell you a story. A year or so ago, we at Bookings began working on our first React-based project after a couple of years of doing Angular. And the first questions that we were faced with is the question that every React developer is faced with: which state management library should we use? And of course, our options were Redux by Dan Abramov and Mobex. And so we began our quest for an answer by gathering the whole team and having a discussion. But the problem was that none of us had any React experience. So making decision regarding usage of one of those libraries was pretty much impossible. So what we decided to do is spread out, do our individual research, and then reconvene in order to make the decision. But then we remembered an important fact, that we were actually working at Wix, full of super smart, genius people that already had the experience with either one of those libraries, and it was pretty useful to ask for their opinion. So what we decided to is gather a council of people from all over Wix, from the guild, in order to hear them out and hear their experience, and then make the decision. But then we didn't stop there, because we decided we had too much data accumulated. And so what would be super helpful is to have a decision matrix that will help us make this crucial decision. The problem was that this whole thing took us over 2.5 weeks without writing a single line of code. And why is that? Well, the answer is simple. Because to us, this decision was so critical, it had to be made right there and then. Without that, there is no chance of us being able to build that product. And if we are to get it wrong, reverting it would be pretty much impossible. But we were super wrong. Because to this day, with multiple React-based projects in production, this is the only project that uses any kind of state management library. You know, we as humans, faced with any kind of decisions, there are only two possible outcomes in front of us, right? We either get it right or we get it wrong. But the stress of getting it wrong actually blinds us from the fact that we don't have a slightest bit of information needed to make any kind of decision. And today, I'm here to suggest that in situations where you don't know whether the decision you're making is right or wrong, there is a third option. Your best option in this case would be to postpone your decision as long as possible. Otherwise, those decisions will have critical implications on the future of your project. So today, we will have a look at multiple reasons why should we be postponing most of your decisions. We will then see examples of things you can postpone during development. We will then explore a thought process that will allow us to decide whether or not we should be deferring the decision. Then we will look at things we can do in our code to enable it, and then discuss costs. So let's start with the why. You know, every project starts with the team gathering around and having some sort of architectural review, right? And the reason we're doing it can be rooted in this definition by Martin Fowler of what architecture really is. And he says that architecture are things which we wished we could get right early on. Why? Well, it's simple. Because things that we decide early on are way harder to revert, and all the rest of the application uses those decisions as foundation. So the conclusion here is that the more decisions we make early, the more impact they will have on the future of our code. And yet, we as developers begin every task and every product with stressing ourselves with tons of questions. Should we use monolith, or should we go microservices? Which UI framework should we use? Which database? Whether we should go SaaS or less, or whatever it may be. But the question is, should all those questions be treated as architectural questions? Should all of them be made early on? Because the truth is that most of the decisions made early are not based on facts. So what are they based on? Well, they can be based on multiple things. For example, they can be based on biases. Maybe previously I worked on some project and I tried something and it didn't really work out for me, and now I'm completely against it. It can also be based on hype. Maybe I've seen some talk, I've read some blogs, and I'm super eager to use this new thing. Finally, it can also be based on stuff like ego. How many of you have been part of discussions where someone argued for something while themselves were not sure that they were even right? The truth is that at the beginning of the project is where we have the least amount of information. Moreover, we as humans, we are okay in evaluating choices given to us. But what about things we don't know? What about options that still haven't unveiled themselves to us? We need to give ourselves more time to understand the unknown. How many of you here heard about Yagni? Awesome, some of you. So Yagni stands for You Ain't Gonna Need It. It's basically a software engineering principle which states that you shouldn't build things based on what you might need. You should build them only when they become necessary. Now, this doesn't mean you shouldn't build flexibility into your code. That just does mean that you shouldn't over-engineer based on guesses. Okay? And I have an example of Yagni for you. How many of you have seen Star Wars? Yay. So this is Yagni. Okay? This was a thermal exhaust installed on Death Star by some smartass who thought it would be super useful, and it really didn't go well for them. The problem with over-engineering is that not only does it produce throwaway code, it also introduces unnecessary complexity that we keep paying for. If there is one thing that warms our heart as developers, is installing new packages into our project, right? Whether it be through NPM or through Maven, right? For multiple reasons. First of all, we love the bragging rights, right? We love to brag to our friends about stuff we got to use. But most importantly, we love this warm feeling of instantly solving a problem, right? We have a problem, we NPM install something, boom, the problem is solved. But this comes at a cost, which we are ignoring. What about the performance penalty? What about the fact that now the onboarding has become more complex? But most importantly, we are ignoring the fact that we may have picked a wrong tool for the job. And one of the reasons that we may be wrong is this thing. This is called a hype cycle, which basically states that every technology goes through various stages of hype during its existence. First of all, the technology is being erected, it is unknown, and then it's being adopted by early adopters who start talking about it and blogging about it and tweeting about it and saying that it is the best thing ever. But over time, those people discover that it does not deliver on its promise, that it doesn't, in fact, solve the problem it should be solving. And then they abandon this technology. And while it's dwelling inside this pit of disillusion, it's either being improved or maybe discovered by new audiences who find a more suitable use case for this technology. And only then, after all this time, does this technology become actually a contributor to our productivity. So the conclusion here is, the more time you delay a decision regarding the adoption of a technology, the more confidence you will have that you're actually picking it for the right reason. Scope change, right? This is the reality of our existence as developers. The problem is that our code, our architecture, our design should support those requirements. So the more decisions we delay, the more time we give those requirements to stabilize, and the more confidence we will have that we're actually optimizing for the right thing. So, given our inability to predict the future, and given the fact that most of the time we do not know whether the decision we're making is right or wrong, your best option will be to postpone this decision and to gain as much information as possible before you actually make it. As long as you don't make this decision after an optimal time, This will be your safest option. So now let's see examples of things you perhaps should consider delaying. Let's start at the very beginning. Dalia spoke a little bit about estimations. So let's start with delaying estimations. You know, at the beginning of your task, surely you are being approached by someone and asked, how long will this thing take, right? And what do you usually do? Just throw out some numbers, right? I feel like 3, maybe 4, and that's it. But the problem is that those estimations are fake. And the problem with fake estimations is that they evolve into fake deadlines. And those fake deadlines evolve into late delivery. But if you think about it, it's late relative to what, right? To random the dates and numbers that we just put out there? We should base those estimations on something. We should gain more knowledge about the problem and about the technical domain before we give out those estimations. I love this quote by Dan Abramov, right? He's talking about state management libraries on front end. You know, you don't go buying glasses before you ever tried reading. Or until somebody thought you were crazy because you started waving at people you thought you knew. Same goes for technology, right? You shouldn't install any package until you encounter an actual need, an actual problem this package will potentially solve. Then you should actually ask yourself, are there any existing solutions inside my code? Is it actually a true need? And then you should ask yourself whether or not it's a need or a design issue. And in many cases, later is true. Developers love to feel like they're influencers, right? Make an impact, right? This is the famous Wix engineering slogan. And one of the ways that we love to make impact is creating super generic Swiss knife abstractions, right? Things that solve every problem in the world, that bring world peace and solve world hunger. But most importantly, they keep our code dry, right? We love the feeling of dry. And the question is, like, are you actually solving a problem? Are there more people that are facing the same problem? Does your solution fit their needs? Are there any existing solutions in your code? All of these are questions you should be asking before you create any kind of abstraction. And one of the practices that can potentially create those wrong abstractions is something that actually comes from front-end development world. It's something that you may have heard of. It's called smart and dumb components. And it's basically this practice that says that every UI component should be immediately split into two. One that actually is dealing with the presentational concerns, for example, a button or a dropdown, and the other that contains all the side effects and all the business logic. And the whole point of this practice is basically to allow the reuse of the presentational components with different data sources. But do you know for a fact that those components will be reused? Or do you know how they will be used? Before you create an abstraction, you should postpone it, and you should learn about how your code is being used. What problem does it actually solve? And only then should you actually create the abstraction. And one of the rules that I love to follow is something that's called the rule of 3, which basically says that you should wait for a third copy of your code in order to be sure that you have enough understanding about its usage. Okay? And only then should you abstract that code. Server API, well, many developers I know begin every task by approaching their counterpart, whether it be on the client or on the server, and immediately discussing the API, right? And mainly about what will be the response of those APIs. But to the server developers in the crowd, what do you guys call this response, right? You have a term for it. Well, a term I'm familiar with is called a view, right? This is what you call it usually. Which to me at least says that the whole point of this structure is to optimally serve the need of the client application. But the problem is, like, how can you create something which is optimized for something that doesn't actually exist? We should wait for our client application to shape itself, understand its needs, and only then should we discuss the contract. Deferring decisions sounds like the right thing to do, right? But the problem is that we as humans, we don't like doing it. For a simple reason that we don't like uncertainty. Okay? And what would be really helpful if we had a well-defined thought process, which will first of all help us to understand whether a certain decision should or shouldn't be delayed. It should then help us understand when will the decision be made in case we decide to delay it, and optimally should allow us to revert the decision if we decide to do so. So today I'd like to show you one of those approaches. It's called real options, which is actually a term ported from financial markets by a guy named Chris Matt, maybe for those of you who are familiar with financial options. And the way he defines real option is that it's a right but not an obligation to do something prior to expiration date. And I have an example for you. Surely many of you have booked hotels and you travel, and you know that every hotel has an option to pay extra in order to be able to cancel your reservation. So in fact what you're doing is that you are paying extra in order to create an option for yourself to decide whether or not you want to go or not. Okay? And if you cancel prior to agreed upon date, you lose a fraction of your fee or you lose nothing at all. And if you don't show up, then you lose the whole reservation fee. The next example is something that should be a little bit more familiar to all of us. Experimentation systems, such as P3, that support feature toggles, actually allow us an option to postpone the decision of when will a certain feature or a code be exposed to our users. It also allows us to revert the decision if we choose to do so. Things like deployment systems, such as Lifecycle, actually allow us to defer the decision whether or not we want to deploy our code to all of our servers by allowing partial deployments, and it also gives us a rollback option. So Chris goes on to define real options using three main principles. First of all, that each option has a value. Okay, and this makes a lot of sense. The fact that I have an option to decide later and gain more information before I do so has a lot of value. Okay, it has value for me. It also has a cost, which will be accumulated in this value, right? The second principle is that each option expires, right? Each option has a condition, it may be a date or whatever, that once it passes, this option becomes unavailable to us, and we can no longer utilize it. And the third principle is that you should never commit early unless you know why. Okay? So what real options give us is, first of all, they reduce stress while making those decisions, while postponing them. Because instead of just saying that you will postpone them indefinitely, you are setting an actual date or perhaps a condition when the decision will be made. Another thing it does is basically it forces you to think whether or not there is a point in even deferring the decision, right? Because when you start thinking about the value, which by the way doesn't have to be a numeric value, right? It just can be something. You're actually thinking whether or not you should be postponing it or not, because if the value of an option is low, there is no point in postponing this decision. For example, if the decision is low impact, or perhaps it's already easily revertible. So now that we know what options are, let's have a look at some things we can do in our code in order to create those options for ourselves. So let's start with TDD, right? TDD, at its core, is a practice which forces us to make no assumptions about our code, because it forces us to write the minimal amount of code possible in order to solve the problem at hand, right? And if you're practicing outside in TDD, basically you're delaying two decisions. First of all, you're delaying on whether or not the object under test will have dependencies. And if it does, you're delaying the decisions regarding the implementation of those dependencies. And once you're done and your tests are green, you now have a safety net which allows you to revert your decisions. and to change your mind and to do so safely because now you have tests that allow you to do so. They give you confidence. The next thing is Spike, which basically a throwaway code which we write in order to create a naive implementation of a potential solution to a problem. Right? And what this gives us, it allows us to gain way more information and way more facts and give out way more accurate estimates when we are asked to do so. It also is very helpful when we're considering to adopt a certain technology, right? Because instead of just playing around in some sandbox, we can take an actual problem we're facing and create a super naive throwaway implementation using that technology and then decide whether we want it or not. Now, this sounds kind of like a waste, but trust me, it pays off really quickly. Ports and adapters is an architecture presented in an awesome book by Steve Freeman and Ned Price. And basically, what they're saying is that our code should be divided roughly into two layers. Right? The inner layer, which contains all of our business logic, all of our domain logic, but has no mention of any technical details. There is no HTTP here, there is no React, there is no database, there is nothing, okay? The layer that handles all of that stuff is the outer layer. This is where we write our React, this is where we make our HTTP calls, and so on and so forth. And what this gives us is a separation, okay? Basically, this allows us to write a large chunk of our application while deferring most of the technical details, okay? And then when we make those details, it will allow us to change our mind and swap out those decisions without most of our application being even aware of the change. I love frameworks, right? We all love to use them for a simple fact that they provide well-packaged, generic solutions to low-level problems. Right? And that allows us to focus on writing our application-specific code. But it comes at a cost, right? We discussed some of those costs earlier. But what we can do is we can borrow concepts from those frameworks before we decide to adopt them. Okay? So let me show you an example. How many of you here are familiar with Redux? Okay, any of you. For those that are not familiar, it's pretty simple. It's a state management library for client. Okay, it manages the state of the application. And the whole point here is that the whole state of the application is represented as a single object. Okay? And what happens is a simple thing. When you interact with some UI component, a button, whatever it may be, it fires an action, an event, so to speak. This event is passed then to a simple JavaScript function along with the previous state, and then it returns a new state of the application, which is then passed to all of the components to be rendered. Okay? So let's have a look at this reducer. Okay? This is what the reducer looks like. As I said, a simple function. It receives the previous state, it receives the action performed by the user, the event, and based on those things, it returns a new state. Here, we have a simple React component. Again, nothing fancy, right? One button which decreases the value when you click it. And inside the callback of that button, we are firing the event. Okay? Now, usually dispatch method is provided by Redux, but here we won't be using Redux. And this is where it gets interesting, because we will implement dispatch ourselves, and we will do so inside a component. And what we'll do is we will use our reducer to create the state of that particular component. Okay? And again, we haven't used any frameworks, we're using pure React code here. And what happens here is that we're using concepts from the framework. We're still enjoying many of the benefits, such as and easily testable code and well-structured code, but we still can postpone the decision whether or not we want to adopt Redux or not. And if we choose to do so, it will be pretty easy because we're using the same interfaces. Any good things in life, things come at a cost. Okay? And deferring decisions can have a pretty significant costs. So if you're postponing decisions too much, what will happen is that you have a potential to eliminate important alternatives for yourself. Remember, options expire, right? And the problem is that perhaps one of those alternatives that has expired is actually an optimal answer to the question you are faced with. If you are part of a small group that makes a decision, or perhaps you're a sole decision maker, the fact that you're postponing your decision can influence your team, that's true, but it can create a cascading effect which will affect other teams that you don't even think about. It can actually cause them to get stuck, okay, because you still haven't made your decision. Unfortunately, postponing decisions means that you should make your things in your code easily changeable. And that, unfortunately, means that makes your code way more complex, okay? And the more decision you postpone, the more complex code your code will get. Lastly, it creates a sort of mental load, because faced with a lot of decisions to be made, some of the decisions you will make may not be optimal. Perhaps it will pressure you into making some sort of a decision just to get rid of it, okay? So I'd like to leave you with a couple of takeaways. First of all, unless you have a good reason, you should postpone most of your decisions in order to gain as much information and facts as possible before you actually make it. And in order to be able to do so, you need to create options for yourself that will allow you to make the decision at a later date. You can use stuff like TDD, stuff like ports and adapters, and stuff like spikes. And lastly, you should be aware of costs, okay? Then they can be really high, okay? Things like mental load, things like code complexity. And you should always ask yourself whether or not it's a cost you're willing to pay. May the force be with you.